Okay, gang, now that we've talked about some of the general concepts and ideas of what evolution is and how natural selection drives evolution, let's talk about some like old ideas that went around before any kind of good science was being done. So it turns out that every ancient civilization knew that the earth changed, that animals must evolve to those changes. The Greeks, the Romans, the ancient Egyptians, Mesopotamians, even the ancient Chinese, all those civilizations knew that life had to change in order to keep up with the changing earth. But the problem was none of them really could figure out how it changed. Now we know it's natural selection that drives the process of evolution, but they couldn't figure it out. And so they kind of like put a pin in that for a while. And it wasn't really until the Victorian age when England was going around and doing a lot of exploring around the world that really we see the start of what we consider today to be really good science. It wasn't good science by any measure of today's means, but it was a lot better than what had come before. So in the 1800s, the Earth was only thought to be about 6,000 years old, and that was based off of just mythological timelines that we got from different religious texts. And from that, philosophers, smart people who can talk and not like me, got together and decided, hey, from the evidence that we have, we kind of think the Earth's only about 6,000 years old. And that idea went on for a long time, but 6,000 years is not a long time for evolution to occur in. And we started to when we started getting to evolution, they started coming up with the concepts of it again. They start realizing they have to reevaluate what we knew. But here's what people did know. Seashells that Sally sold by the seashore, where are they always found? Well, in the riddle, they're found by the seashore, right? They grow in water. That's where bivalves live. And water is always at the lowest points, right? Because water runs down. And so seashells are found where there's water. So as we explored around the globe, we started noticing, hey, look, I found some really cool seashells. And they're embedded in rock. And they're at the top of a mountain. So how did something that we know grows in the oceans at the bottom of the world end up in the rocks at the top of the world? That's when we started really having to evaluate what is it that we think we know about our planet. And as we explored more, we started noticing different things that also did not fit the preconceived ideas of how we thought the world worked as far as the age and how the Earth structure itself happened. And so this guy named Huvier came around and he said, oh, well, it's catastrophe. Obviously, if there's a big upheaval that happened real fast, that would have shoved the bottom of the oceans up into the tops of the mountains and explain what we see. And so people started saying, okay, cool. It fit the 6,000-year age of the Earth. They, from our standpoint, happened a little over 2,000 years ago. That gave it enough time for everything to calm down, but it's still far enough back in time to where it wouldn't be in recorded history anywhere. And that explained it. And so people kind of go, okay. So the Earth moves a little bit every once in a while, and a quick and giant upheaval. And they call it catastrophism. Here's kind of my idea of how I think it probably happened. Like, why not a dragon busting out of the ground, flying around, destroying everything? That's a catastrophism. So there it is. That's catastrophism. We know today that's not how it happened, but they didn't know that. So some other old ideas that they had. There's this guy named Lamarck, and if you ever hear my lecture on genetics, you hear me talk about this guy a little bit. But he believed that animals changed not because of the evolutionary process, but because of a magical substance called fluida that moved into the areas of the bodies that needed to change. And this is what he used to explain how giraffes got longer necks. So the idea was that this substance would move into their neck and make their neck longer. And because they had longer necks, then their offspring would have longer necks. So natural selection versus Lamarck. So Lamarck, if you can't reach the branch, just have your fluida, make your neck get longer. Now you can reach the branch. And since you have a long neck, when you reproduce, your offspring will also have long necks. But he couldn't really produce the substance. Like, can you show us fluida? No, you cannot, because it's imaginary and it doesn't exist. Natural selection said that you're naturally given a longer neck. It's a random variation that you're given. So you have a taller neck. Because of that, you can reach more food than the shorter necks. because you're getting more food, you can reproduce more than the shorter necks. And that when you do reproduce, that long neck is passed on to at least some of your offspring, and therefore it becomes more common in the population. So over time, we start seeing giraffes with longer and longer necks. Giraffes actually have the same number of vertebrae and nerves in their necks as we do. It's just they're elongated. Because then, evolution doesn't create something for nothing. It modifies pre-existing structures. So, yeah, we really weren't sure about that whole fluida stuff. I'm guessing that's probably what fluida looked like. I have no idea. Neither did Lamarck. But no, that's not how giraffes got longer necks. It was through the process of evolution. That's how giraffes got longer necks. So that's one idea that we had to kind of contest with for a while. And it wasn't until the 1800s that we start seeing the emergence of this brilliant scientist. Of course, all y'all know Charles Darwin. I'll call him Chucky D because that's just what I call him. So here's a picture of him when he was old and a picture of him when he kind of started his career. But what most people don't know, it wasn't only Charles Darwin. It was also a guy named Alfred Wallace. And Alfred Wallace and Charles Darwin, at the same kind of the same time, independently of each other, came up with the idea that nature is also capable of selection, and that it's natural selection that drives the engine of evolution. So most people know a little bit about Charles Darwin's life. He was born in London. His dad was a doctor, kind of a prominent surgeon. And he grew up in an estate outside of town and had, there's no Nintendo, there's no electricity, so he just walked around and followed bugs in his yard. And he was really good at sketching, and he was really kind of like showed signs early on of being a really good naturalist. Today, for us today, it'd be a very good biologist and ecologist. And when he got into school, back in those days, whenever whatever daddy did is what you were going to do. His dad was a doctor, so he actually went to medical school. So at the ripe old age of 16, he goes to his first day of medical school. Big amphitheater, lots of students in there, 16, 17 years old. Their professor walks in and says, "Hey, we got a great show for you guys today. We're going to show you an amputation." And two big burly guys drag this guy in who obviously had an arm injury, most likely in a farming accident or a machinery accident, and it was gangrenous and it had to be amputated. And the guy was also drunk. And so they slap him on the table, and they strap him down. The doctor, while he's talking to the students, is rolling up his sleeves. He pours a little alcohol in his hands, pours a little bit on the saw, and pours a little bit more down the guy's throat, and just starts sawing this guy's arm off in the middle of his lecture. And Charles Darwin did probably what I would have done, and several other students did the same thing. They all ran outside the building and threw up in the bushes. It wasn't really cut out for Charles Darwin. Not going to be a doctor. So he goes back home, tells his dad. Dad's a pretty progressive thinker and says, "Okay, what do you want to do?" Well, in society at that time, it was kind of commonplace. If you didn't do what Dad did, then you became a member of the cloth. So Charles Darwin actually, rather than going into a monastery, just decided to take school, and he actually finished a 4-year degree in theology. He was a theologian. And most people don't know that about him. That's a pretty cool fun fact. It was afterwards that he actually, he had a little trouble in school, not for anything other than he was smarter than a lot of professors. He'd go to one philosophy professor and ask a question, get answer A. He'd go to another one, ask a question, get answer B. He'd go to another one and ask the same question again and get answer C. And he's like, I'm asking the same question, but I'm getting completely contradictory answers from each other. There's not a lot of cohesion in this. There's not a lot of evidence-based reasoning with this. It just kind of seems like people are making stuff up. So later on, he actually, after he graduated, some of his friends said, "Hey, look, there's this ship called the HMS Beagle that is going to be leaving port soon. They're going on a 5-year journey around the world. They're going to see some really cool stuff, and they need a naturalist. They need somebody to collect species who's really good at doing cataloging and drawing the species and making notes and studying them." And Charles Darwin was all about it. So he hopped onto the HMS Beagle, and about 5 miles out of port, he throws open the portcullis, which is a window on a boat, and throws up because he suffered from immense seasickness. Some of the other stories is that he, being not a sailor, he was actually a pretty educated guy. So was the captain. And they would actually have dinner together a lot, but they did not see eye to eye. The preacher was actually more of a fire and brimstone. The preacher, the The captain was more of a fire and brimstone kind of theologian, whereas Darwin was more acquisitive and more New Age thinking for his time. And so they used to butt heads a lot, but they had a lot of respect for each other because they were both intellectual people. But whenever they finally got to the coast of South America, Charles Darwin got off the boat and said, "I'm not going to get back on for a while." He took a bunch of guys with him, 20 to 30 guys. He'd walk down the sea, from one port to another, essentially, and through the woods and the rainforest, and he'd collect all kinds of stuff. So this expedition started with a bang for him. He'd get back to the boat, trade out with another 20 or 30 guys, drop off all supplies, pick up new ones, and head down the coast again. He didn't really like being on the boat, but eventually he had to get back on the boat, and they sailed around and adventured into different places, and then they ended up this little archipelago of islands called the Galapagos. And what's really neat about the Galapagos is that it's a collection of a lot of different islands, but because of where it lays for its geography, it's at the converge of two major currents. One is the wind currents, the other is the ocean currents. Deep water on one side brings up colder climates. Shallow water, it's much warmer on the other side, brings warmer winds. The islands are very different from each other. The topography changes. Some are taller, some are flatter, some are more desert-like, some are more tropical-like, some are more just island-ish. And they're so close to each other that they share a lot of the same species, but the species living on the islands become isolated populations, and evolution kicks in, and we start seeing them not just be randomly different from the other species, from the same species on other islands, but they're specifically adapted for life on their island in ways that make them different from the other species. And it was Darwin who found this little treasure trove of evolutionary adaptations, and really this is where he gets a lot of his great information. So a lot of people think, oh, it's Galapagos Islands, so he studied Galapagos tortoises. No, reproduce way too slowly for him to study, though he did make some notes about them. He actually studied finches. That was the major line of evidence, the major species that he collected that led to his reasoning for natural selection being the culprit who drives evolution.